Alright, so the previous upload of the video went silent after about 1 minute 20 seconds, so take two. Alright, so essentially what we have is x1, x2, and x3, psi from -1 to 1 to 0. So this is now in space where this thing is. We know that this thing can be anywhere in space with coordinates x1 here, a coordinate x2 there, and a coordinate of x3 in the middle. Okay, so what I want to look at is what happens with the special case. Well, before we do the special case, let me just write down this isoparametric formulation. Okay, so I think already indicates, let me just double check this. There was that video already from, yeah, that's the previous video for isoparametric. Okay, so let's write down what is x as a function of psi, and explicitly, so that we just have it. So it's -1/2 psi, 1 minus psi, yeah, yep, x1 plus, then I'll put them, let's put the x3 in there first, so it's then going to be 1 minus psi 1 plus psi x3 plus x2 multiplied by psi 1 plus psi. Okay, so and it's a half. So that's what we have. Okay, so that is essentially x as a function of psi. Okay. So now what I want to do is to say that's all good and well. Depending on what I make x1, x2, and x3, this will have various implications. Let me put this x2 at the back here, so here to see. Okay. This is not great. Okay, so that's all clear. So let's do the sort of first special case. And what I want to focus on, special case, okay, of when I choose this mid-side to be in the middle. So if x3 is in the middle, it's essentially just the sum of these two divided by 2. So if I make that choice. But what I want to specifically look at is, for now, I'm going to look at specifically at what happens with dx dxi and see what that relationship is. And then I'm going to ask you to infer from that, what do you think is the relationship in terms of x? Okay, so let's do it so that we build in a bit of reflection on purpose. Okay, so first off, before I do this substitution, I'm just going to first check the derivatives. Okay, so let's just, so this is what we want to be working towards. So that we see if we choose it in the middle, what's implications of that, or what happens. But in general, let's just first see what happens with the x dxi first off. So let's compute the x dxi. So it's minus, make sure it's on the board there, so it's minus a half. The derivative of this is minus a half. Then it's going to be minus, this is plus, so this multiplied by this is a plus a half psi squared, so that will be plus psi. And all of this multiplied by x1 plus, then this derivative here would be 1 times x3 is 1 times 1, is cancels out, these cross terms cancel out, and minus psi squared. So this will be essentially then minus 2 psi x3. Then this one here on this side will be a half. Yeah? Why do I have a minus here? That's fine, yeah. So it's a half, it's fine. A half psi, which is a half. And then this is a half psi squared, which is just plus psi x2. This is the derivative, how it looks. Okay, this is all good and well. Now we can start saying, let's focus towards the special case. Okay, so this is still valid in general. I've not made a substitution for a special choice for x3 there. So this is in general the case. And you can see that size are all present here. But let's make that special choice. Let me see, I've got space here. That's good. Make a special choice of x3 equals to this. Okay, so let's say minus a half plus psi x1 plus Hazelmoss, yeah. Okay,